Circles are one of a large family of curves called conic sections. We're not going to meet the entire family of conic sections, but I want to take a moment and remark on them. Conic sections are any curve whose equation can be written in this form. So we have an x squared term and a y squared term. An x term, a y term, an x times y term, and a constant, all equal to 0. This is in standard form if it's arranged so that all of that is equal to 0. Everything is integers if we can possibly make that happen. Occasionally we'll be stuck with an irrational number in here. And our leading coefficient is positive. The family of conic sections includes the circles. It also includes a bunch of curves that we've met before, and one set of curves that we're going to meet in a little while. If b is 0, so we have no y squared term, and e is 0, so we have no xy term, but a is not 0, we have something that looks like that. Now that's a function of y. We can solve that for y. And if we do that, well, we'll have dy equals, subtract everything else, negative ax squared minus cx minus f, divide by d, y equals negative a over d x squared minus c over d x minus f over d. That's what we get if we solve for y. That's something times x squared plus something times x plus something, where little a is negative big A over d, little b is negative big C over d, and little c is negative big F over d. And notice, since big A is not 0, that's not 0 either. If we solve that for y, we get this very familiar quadratic, which is the equation of a parabola. If all of the weird terms are 0, and we just have a number times x plus a number times y equals another number, that's also very familiar. That's a linear equation, so its graph is a line. Finally, if our a and b are 0, so we have no x squared terms and no y squared terms, we have something that looks like this and has this odd xy term in it. We can solve that for y as well, though. So we start with cx plus dy plus exy plus f equals 0. I'll collect all the terms with y's in them on the left, all the terms without y's on the right. dy plus exy equals negative cx minus f. On the left, if we factor out the y, we have y times d plus ex, and on the right we have negative cx minus f. Dividing both sides by whatever this thing is, which will not be 0 for most values of x, we get y equals the fraction negative cx minus f over d plus ex. I'm going to switch these two terms around just so I have an x term first in both places. So solving for y, we get y equals negative cx minus f over ex plus d, which is a rational equation. We didn't learn to graph rational equations way back when we studied them, but we will learn to graph this specific kind of rational equation in a little while. So Several of these conic sections are things that we already know how to graph or will learn how to graph. Circles are another example of this type. In a circle, our a and b have to be the same. So the x squared and the y squared have to have the same coefficient. And they can't be 0. Because if they're 0, then we're in one of those other cases that we just talked about. And then to be a circle, we have to have e be 0. So there's no xy term. Our circles are going to end up looking like ax squared plus ay squared, same coefficient, plus cx plus dy plus f equals 0. And that will be standard form.